in the interest of time, let's actually bring all the paper speakers together and have our mini panelist session. So now you can ask questions to any of the paper. And so maybe we can start with Mike's question to paper number 3. Mike, do you want to try again your question? Mike Ching? You're still muted. Okay, then next, Shwata, you asked a really great question on Slack. Would you like to ask it live? This is for paper number 1, Witcher.
Hello?
Yeah, Shwata.
Yeah.
If you can turn on your video, that would be great.
I don't see an option to turn on my video. I think I'm an attendee, so I can't share my video.
Okay, yeah, I allowed it.
Yes, but it will take some time.
Okay, then you can just ask your question.
Yeah, so I was curious to know, why is your solution limited only to key value stores? And is there any fundamental property of Witcher which hello, I'm sorry. I was rejoining as a panelist. Was my question clear?
Yeah, the first part of the question is here. The second, is there any fundamental property of Witcher?
Yeah.
I read your question in the Slack. There are 2 questions about this generalizability of the Witcher in the Slack. So for the first key idea, which is the likely invariant, likely correctness condition inference, this ideally can apply to any NVM programs. This is general. But in the second part, the output equivalence checking, since if you remember in the slide 7, so we have to re-execute the 2 oracles to get the 2 oracles. So this requires the deterministic. I would say this is the limitation of the output equivalence checking. The program has to be deterministic. Did I answer your question?
Yeah. Another doubt that I had was, in your slides, you mentioned that the Intel x86 model can guarantee ordering and durability. How can you say that it can guarantee durability? Ordering, I get, it can be guaranteed using CL-flush operation or CL-flush OPT operation in conjunction with SFENS. So that I understand. But where is durability guaranteed?
Durability and the ordering and so the durability is guaranteed in this way. You have to flush and then fence, then you guarantee the durability. And the ordering is also guaranteed by the fence, because after fence, if you have write A, flush A, fence A, and then write B, then before writing B, A must be persisted before writing B.
Okay, maybe we can take this offline.
Sure. No problem.
Yeah.
Thank you.
Yeah, thanks for the talk.
Okay, our next question is Wenqing.
So hi Yongle, I have one question about the paper. So in the DOP tester you mentioned, so how do you design your workload to trigger and detect those upgrade failures? And does those workload need many application-specific knowledges? Yeah.
Thank you for the question. So we have mainly 2 types of workload. One is we directly use the default stress testing tool that comes with the distributed system. And we don't do too much. We just use a default workload by the stress testing tool. And the second one is that we try to use the workload that exists in developers' unit tests. And we try to extract those client-side operations inside this unit test and synthesize them into a program that can execute a sequence of client-side requests to the cluster. So that's a second type of workload that we use.
Yeah, I see. Yeah, so how much effort for the second type of workload you need to pay? So if you want to extract the unit test from the developer's code.
Yes, good question. So Basically, we developed this specific this simplified compiler, and in order to apply this compiler on a new system, you need to provide a list of client-side operations, right? So that you target in this distributed system, and how do you want to translate them to, let's say, client-side requests that can be sent over the network to the cluster that we set up in our testing environment. So this is the mapping that you need to provide. The client-side operation in the unit test maps to client-side operations that you sent from over the network.
Okay, I see. Yeah, thank you. Yeah, great work.
Thanks.
Okay, so in the interest of time, we'll take one last question from Mark Shapiro.
Yeah, hi. This is a question for the third speaker about your programming model. If you don't have a commit record, how can you abort? I mean, transactions sometimes abort. Hello?
小健.
Sorry, I don't hear the question clearly.
Okay. It's about your programming model. You eliminate the commit record, right?
Yes.
If there's no commit record, then what happens to transactions that abort? If there's no commit record, there can't be an abort record either. So how can you abort a transaction?
CCME does not handle the transaction abort because it should only deal with the persistence phase of the transaction. I think the abort is with the concurrency control in the upper layer system, such as the system can abort the transactions before it persists the transaction. So I think the abort algorithm is algorithm to the CCME design.
Okay, so you have only very short transactions. That's the idea.
Very short? No. CCME does deal with the persistence phase of the transaction processing. It does not provide the concurrency control.
Okay, I think that's orthogonal, but I'll accept that.
Okay, thank you all to all the speakers for excellent talks, and thank you all for a great session and great Q&A. And bye, and I'll see you guys in the next session.
Yeah, so let's actually invite back Shinwei, Yongle, Junwen to join this panel for the next 10 minutes. Please turn on your video. Okay, so I will start with a meta question. You know, we all know that consistency is always a very important topic and a key challenge in systems, correctness. There are, in many different forms. We have seen some very interesting work in this session. What I noticed is there are, two different approaches in some sense. The first two papers are about finding violations, consistency violations, and we very successfully in two different type of systems, right? One is on non-volatile memory and the other on distributed systems. And the third talk is actually takes a very interesting and different approach, which is more along the lines of correctness by design. So I think Xiaojian was talking about how to design this non-volatile memory express that's crash consistent and also performant. So I'm just curious, would you share your views on those two different approaches from your experiences? How do you choose one over the other? What are the pros and cons?
No.
Yeah, Xiaojian, you can start.
I don't. Sorry, I don't hear the last question clearly.
Okay, so I guess the question is, you take approach. It's more like design the right abstraction that has the right properties, right? So by design, this is correct. I use your interface, then I get crash consistency, right?
Yes.
There will be no bugs. The other two pieces of work, which is also very important, they actually detect bugs. And I'm just trying to understand, maybe from your perspective, why do you decide that you should provide an abstraction rather than expose all the flexibility to the users, right? And by this kind of design, you kind of eliminate the possibility of doing having violations.
Yes. Yes.
Can I take the question first?
Okay, sure.
Yeah. So I will take the question from my side, and I think this is a great question. Actually, I think these two approaches complete each other. So during my period for detecting bugs, there are several bugs for it is because the false design, and there are several bugs it is because the mistake by your implementation. So even though you have a correctness design, like the bugs we detected using your example is from the OSDI paper, the design is perfect, but they have the implementation mistake. So and our tool can help them to make this bug free, even though you write that in a buggy code, and even though your design is good. And so I would say this we will always have these two directions in the near future, because even though the design is very important and also the implementation is important, and we complete each other. So that would be my answer.
Great. Yula, do you want to add anything?
Yeah, I can explain a little bit from their topic, but in our project, we do have a data serialization library, which provides this data format declaration interface. If you declare data format correctly, they kind of ensure that your data can be parsed and can be serialized correctly. So I also agree that the bug detection and these libraries, they are complement to each other. So sometimes these libraries, they have their limitations. For example, the problem I mentioned, protobuf does not support polymorphism. And there's a good reason for that, because it supports different languages, C, C++, Go. Those languages do not have polymorphism, right? So there's a good reason for the limitations. So and developer has to do some customs wrapper or data serialization around this because of the limitation. And so that's where the detection tool can help to complement.
Mm-hmm. Yeah, great. Juman, do you have anything to add?
Yeah, I agree with Yongle and also Shinwei that these two work completely. Well, after we detecting those bugs, we find that sometimes the reason why we detect them because the previous work has some limitation, and then after we detecting these bugs, we find that there could be a potential directions to have a better abstractions that can also improve the work. So I think it's kind of evolution, and you improve each side of the work, and finally we can reach a bug-free work. I'm not sure.
Yeah, it'd be great to have a bug-free world. So we actually have a lot of verification work. I think even in this conference, there are papers on verification, which is another approach that's very helpful. So just to follow up on this question, especially, I think for the first two papers, you guys have done a wonderful job in detecting a lot of, very interesting bugs, for the first time. I'm just curious, the methodology you're using. For example, I look at the Shinwei's work. There's a likely invariance. There's some domain knowledge that you're leveraging, and similarly, like for the software upgrade, you are focusing a lot on serialization and mismatch. What is the right methodology for people who are sort of interested in looking at failures, looking at reliability, consistency in general? What kind of experience or advice you want to give to others working in the same domain? How much hard work that you have to do to find those bugs and so on.
I can start. So yeah, so I think one advice I would give is always start from the raw data from the real world. That's where the insight comes from. Yeah, that's actually the most important advice that I can give.
Yeah, I totally agree. So we spent a month to do a bug survey in this area. So we design our system from the observation. We have to do the survey and categorize different bugs and get insight from them. And then what we will do, we will review all the previous work and find the challenging and the shortage of them. So, but still, I totally agree with Yongler. So the observation from the real world is very important. That's the foundation we have for bug detection.
Yeah, since Junwen just joined Facebook, now you're in the industry. A lot of work you did in this paper is from open source and so on. I'm just curious, whether your perspective has changed, whether your work you think is actually relevant and useful in the industry.
Yeah, that's a good. Actually, I haven't started yet, but I can
Okay.
I can share my experience while I was interning there. So people there also do a lot of developers there also have a lot of problems, so they will report, they will show them in the forum. So if you want to really look at the problems, you can just like what I do in my research project is that I look into real world problems, not only this upgrade failures, previous my bugs, and I studied these performance problems in web applications. We go to their issue tracking systems, we look how they discuss and how they write the patches and how those things work to understand them. And then in the companies, if I want to solve their problems, I probably need to search their forum, our forum, and see how these problems that occur most frequently and try to solve them. Yes,
great. That's a great point. Yeah, thanks, Juwen. I think the other thing that's also very important is how you pick problem. You sort of touch on that. Since Shinwei's work and also Xiaojian's work are also both on crash consistency in non-volatile memory. I'm just curious, why you choose this topic. Maybe that's the last question I'm going to ask, and then we conclude this panel. Xiaojian, do you want to go first?
I choose crash consistency because it's a challenging and classic problem in the storage system. And I find that crash consistent overhead is very severe in modern storage systems. So I try to adjust the performance overhead of crash consistency, by a simple and generic way. So this work is inspired by our previous work in OSDI. So we find that some of our key ideas from the previous work can be applied and extended to the driver layer. So we propose to integrate these ideas to the generic device driver. And we also agree that using tools to detect the bug is also very important, because our design is the design of the ME is correct intuitively, but in implementation we find that many bugs. So we use a crash bug detect tool called Crash Monkey to find the bugs in our implementation. So
now you can get a better tool from Shinwei,
yeah.
I think. Yeah, so a great piece of work, by the way. I really love the work you're doing. Shinwei, maybe I'll give you the final words before we conclude.
Yes, thank you. Yeah, when I started this project, NVM has not been commercialized yet, but we already see the potential because there are lots of research on that, even though this hardware is not commercial. And by design, we think the NVM will be revolutionize the storage stack because it introduced a new layer between DRAM and the disk storage. And lots of industry are very interesting, and Intel pay lots of attention and lots of efforts on it. So we see the potential for the hardware. And at that time, there are only several bug detection papers for that. And just in this year, we have like 5 papers of that. So I think I think this is very interesting work and it's a very promising direction. So we worked on that like 1 or 2 years ago. Yeah.
Great choice of problems. Thank you so much, Xinwei, Xiaojian, Yongle, and Junwen. Very congratulations on the SOSP paper again.
Thank you.
Thank you.
Okay,
Thank
that
you so
concludes
much.
our panel. Yeah, thank you so much for joining us.